Good evening, all of you. Very good evening to all of you. Welcome, you guys. Welcome, you all. I hope we are live. So, here, will you please confirm this audio video? Will you please confirm this audio video is clear to all of you? I think we are live. Please confirm the audio video is cleared. Yes. Fine. Chalo, let's start our discussions, everybody. So here in this series we are going to discuss some of the most expected questions, and आज हम डिस्कस करने वाला कुछ टू सब्जेक्ट वी आर गोइंग टू डिस्कस. इसमें हमने नेटवर्क्स एंड डिजिटल के बारे में हम डिस्कस करने वाला, कुछ खास क्वेश्चंस हम डिस्कस करने वाला. आज नेटवर्क्स में ही हम थीरम्स का टॉपिक में डिस्कस करने वाला, एंड डिजिटल में कॉम्बिनेशनल सर्क्यूट्स. नेटवर्क्स में थीरम्स वी आर गोइंग टू डिस्कस, नेटवर्क्स में थीरम्स टॉपिक्स, एंड डिजिटल में कॉम्बिनेशनल सर्क्यूट्स वी आर गोइंग टू डिस्कस. कॉम्बिनेशनल सर्क्यूट. चलो, let's start our discussions, all of you. All of you. Now, before this, we have a small announcement. We are starting a new batches for the GATE and ESE aspirants, and so January 28th onwards, we are starting a new batches. You can see now here, and this is a batch C, and you can find the top educators team. You can find in the single frame, and you do follow these batches. And to enroll for these batches, you can join Unacademy Plus by using the code of B.V Reddy. By using the code of B.V Reddy, you will get a great discount, and apart from this, you will get my personalized guidance from me. And these are the new batches for 2025 के लिए हम शुरू करने वाला. You can see, and these are the key differentiators for these batches. And this batch is for the GATE, ESE, IRMS, and CSE mains. So for all the different type of exams, yes, you have a key batch is sufficient, right? And here the Bunyad batch for 2025 के लिए you do follow these batches. And another great announcement, there is chance to get the 30% of discount, and this offer which is valid up to 31st, this offer is valid. 31st, this offer is valid, and try to utilize this opportunity before going to expire. And you do remember the universal code B.V Reddy. By using the code of B.V Reddy, you join the Unacademy to get the great discounts. Right. And these are the GATE and ESE top rankers for 2022. And we have started the new batches for the IRMS mains also. And so we are starting a mission IRMS as well as CSC 2023 के लिए हमने एक बैच भी शुरू किया. You can find the top educators team here, and you can plan this Unacademy subscription for GATE and UPSC mains के लिए. Combo subscription is available right now. You can use the code of B.V Reddy and to enroll for these courses. चलो, and let's start our discussion, all of you. And आज का सेशन में हमने we are going to discuss about the networks में theorems, and digital में combination we are going to discuss, and take the problems one by one. Right. And so the subscription details and all which is available in the website, and you can go and check the subscriptions and you can enroll for it. चलिए, so take the first problem, all of you. The theorems. आज हम डिस्कस करने वाले theorems, नेटवर्क्स में theorems and डिजिटल में combinational circuits we are going to discuss. Take the problem here, all of you. And when the given that VSC is given as 120, it is found that I1 value given, V2 value given, and the power across the resistor R3 is given. Now they made the Vs value now 105. So that means initially Vs, initially my supply voltage, how much is the supply voltage? You can see now here 120 volts. Thereafter the Vs, they made this as what you tell me the new value of Vs. If I the new value of Vs they made as a 105. That means इसमें क्या किया here? So here the voltage को supply voltage को कम किया ना. So means we can say the relation between the initial value and final value of supply voltage, which is given as what we can say the ratio. If we see here, this is a new value. I can say which is given as 105 by 120 here. So that means हाँ ये उन्होंने क्या किया इतना. So here and this value which is equal to 21 and this is what you tell me now here 24. Isn't it? 21 by 24 से multiply किया. Now here, so here what we can say now here 3 sevens 3 8, 7 by 8 से multiply किया ना. Tell me supply voltage को. So the new value of supply voltage Vs, which is given as what we can say here 7 by 8 into previous value. हाँ ना बोलिए. Here the coefficient, how much the k value tell me 7 by 8. अगर 7 by 8 से multiply किया तो क्या होने वाला tell me. अगर according to the homogeneity property, yes tell me now here homogeneity property. अगर सोर्स को k से मल्टीप्लाई किया तो क्या होने वाला. The response in each element is also multiplied by the same constant. So that means the new value of k, if I say this as new value of k, क्या होगा इधर 7 by 8 times the previous value. How much here 3. So which is equal to 21 by 8. Next, yes, next value here V2. Yeah, tell me now here V2 dash, which is given as 7 by 8 into how much the initial value 50. Tell me now which is equal to 35 by 8 and whatever the power you tell me now P3 if I say. So here voltage multiplied by constant k, current is also multiplied by some constant k. As a resultant of this, power multiplied by the k square times k square into initial p. Tell me the new value of power. You tell me k square means what I can say here 7 by 8 whole square into p3. How much the p3 new power you tell me. Previous power is 30. So tell me the new value of power. From this do simplify. Tell me the option. कौन सा option होगा? Tell me जल्दी. Yes, how much this value? So 45.9, isn't it? So कौन सा option tell me here? Option C. Done. Everybody fine? Chalo, next problem. Take the next one. The linear network contains only resistors. Only resistor. They get the two sources they given. You can see now here IS1 and IS2 two sources are present. And it is found that so Vx value found to be 80. Now when IS1, IS2 given, so Vx value given as 0. Now they are asking to find the Vx value. Well, as we know according to SPT superposition theorem, according to SPT, what we can do here, the response in any element can be expressed as what you tell me now here Vx, which is we can express as a linear combination of individual responses. Tell me IS1 plus what I can say here K2 into IS2. Tell me all of you. The response in any branch can be expressed as linear combination of individual responses. Right. So initially they given Vx value given as 80. So which is given as what I can say K1 into IS1 is how much 8 plus K2 into IS2 value 12. So this is one linear equation. Second, Vx value 0 when? So that is K1 into what? Minus 8 plus K2 into what? 4. Now you can see now we have two equations and two unknowns. Two equation, two unknowns. By solving these two equations we can get the K1, K2 values मिलेगा हमको बोलिए. K1 value कितना, K2 value कितना, जल्दी बताइए. How much you will get the K1, K2 values, tell me. So K1, by solving this thing here, K1 I think so K1 हमको क्या मिलेगा, this is, so here 2.5 and K2 value which is equal to 5. So K1 K2 values मिला. So इसके बाद अभी क्या करो बोलिए, the response Vx which we can write it as, tell me now here, 2.5 into IS1 plus 5 into IS2, tell me. So from this what I can say now, Vx, the new value they given, the when IS1 IS2 value given as 20, so means what I can say, 25, 2.5 into IS1 is a 20 plus 5 into, and this is IS2 now. Here this value which is equal to 20. Yeah, simplify, tell me how much is Vx value, tell me. So which is equal to 150. Then shall next take the next problem. In the given circuit, superposition is applied. Superposition is applied when V2 is set to 0. V2 is set to 0. That means this value 0 means this is deactivated. V2 is set to 0 and they given the current I2 value given as minus 6. And this current they given as minus 6 they given, right? And this current they given as how much here? Minus 6. Right, so that means this direction current which we have this as plus 6. Right, next, when V1 is set to, so that means this is plus 6, means I can find the voltage across this element we can find. So how much this voltage you tell me now here, which is equal to 24 volts. How much this voltage is a 24, and you can see now here this is 24 and this is 0 volts here. So this voltage I can say this is a 24, this voltage is also 24, means this current I can call this as a 4 amps. Right, this upward current, this current is 4 amps, this is 6 amps, isn't it? So from this what we can say now here? Now, so from this what we can say now here, can you tell me the how much is I1 value, this is I3 value 4. Now you tell me second case. So in this case by observation what we can say, I3 value minus 4 now here. Next, when V1 is set to 0, the current I1 is plus 6. Okay, now take this thing here, when V1 is set to 0, when the V1 is 0 and what they given now, this current I1 is given. With this we need to find the values. This is my V2. Right, so then which is given as what we can say here, 3, and here this is my 4 and this is my 6. Here tell me here. No, here this voltage, now here this voltage 24, and so here when the V2 value this is shorted now, so then same voltage will appear here also. Right, so now you tell me now here V2. So they given this when I1 value given as how much, you tell me now here, 6 I1 value. So this current is given as what we can say here, 6 amps they given, right? This is 6, that means how much this voltage value tell me, and which is equal to 18 volts. Then what about this voltage? You tell me this is also 18 volts only na. So that means, can you tell me this current you here, which is equal to 3 amps. So this current is 3 amps. So you can see now here I3 downward direction, which is equal to 3 amps. Now here this current is downward 3 amps, right? Now here I4 is for the total current. Let us say I1 dash and I double dash. So what is the I3 value, net value? Tell me. I3 dash plus I3 double dash. So how much this value? Tell me. -1. -1. So downward direction we require. Now they given the current I3 is downward. That's why it is -1. Upward is +1. Downward is -1. Right. Next. Take the next problem. Yes, this is also almost similar to earlier problem. Only tell me. In the given network, when Vs value is V0, I given as 1 ampere. Okay. I given as 1 ampere. That means this current is 1 ampere. Right. This current is 1 ampere. Okay. When Vs is equal to V0. Now they made the Vs is equal to V0. Agar excitation multiplied by some constant k, then the response in each element is also multiplied by the same constant. Excitation is multiplied by 2, so response is also multiplied by the 2 only. Now tell me. So that means this current, when this is the 2Vs and this current is how much? You tell me. 2 amperes. This current is 2 amperes. Means, so this voltage, which we can say 2 volts, and this is a 2 amps, and this voltage is a 2. This is what you tell me now here, 8. And you can tell me what is this voltage here. Now here this is 4 into 2, 8, and this is now this voltage, which is equal to 10 volts. You see carefully. Keynote series of signals and systems. So actually I didn't do the signals and system ना. Signals and system का keynote series मैंने नहीं किया. So I think so some other faculty ने किया. You do check. You do contact that faculty. Okay. Yeah, this is 2 now. So this is 4 volts. And tell me now here how much this voltage here. This voltage is 12 volts now here. So can you tell me this current here? Now this current is 4 amps. And that means this current is 6 amps now here. 4 plus 2, 6. And so then this voltage, which is equal to 6 volts. This is 6 and this is 12. So that means this is 18. This is 18. And that means this current is how much here? 3 amps. We need this current only required now here. We need this current only. So that means how much is I1 value? Tell me. Which is equal to 3 amps. Done. Next. For the circuit shown in the figure below, some measurements are made and listed in the table. Now they are asking, which are the following expressions they are asking. Now here you can see, now here we have two sources are there, Vs and Is are the two sources, and IL is the response element. As we have seen earlier, the response in any element can be expressed as what? You tell me. Linear combination of individual responses. So that means IL, which we can write it as K1 into Vs plus what? You tell me. K2 into Is. Linear combination of individual responses, and it has given the response. You see this thing here, when it is a 2, which is given as K1 into Vs value 14 plus K2 into Is value 6. This is one equation, and 6 is equal to K1 into 18 and plus K2 into what? 2. So we have two equations and two unknowns, you see. From this, can I get the values of K1, K2s? Tell me the K1 value, what I will get here? K1, so we will get this as a 0.4, and this K2 value which is equal to minus 0.6. K1, K2 हमको मिला. इसके बाद what I can do here? The response IL, which we can write it as, tell me, 0.4 into Vs minus 0.6 into Is. Fine. When R is given as a 10, VR is given as a 20. Okay. When R is given 20, VR is given 30. Now, what we can do? According to the Thevenin's theorem, this complete network I can replace with Thevenin's model. Thevenin equivalent से replace करेगा. This is my load, I can say. Tell me now here Thevenin's equivalent circuit. And so this is my VTH and RTH, Thevenin's model. And this is my load, this is my R, right? So here you can see now here this voltage is VR. Now you see this thing when R equal to 10. So if I can write the KVL in this loop, and this current is I, if I call, tell me the equation here. The VTH, which is given as RTH into I plus VR. Now you can see now here VTH, which is equal to RTH into I. So when R is 10, so here VR. So how much this current is at 2. 2 plus how much the VR is at 20. This is one equations. And R is 20 when VR is 30. Tell me now by using this relation VTH, which is given as RTH into, tell me now here how much this current is 3 by 2. 3 by 2 plus VR is 30. Now we have two equations and two unknowns, you see. We have two equations and two unknowns. By using the two equation, two unknowns, can I get my VTH value and RTH value? By equating these two here. Can you tell me how much will get the VTH value and RTH value? Tell me. By equating these two equations, we can get the VTH value. हमको क्या मिलेगा? 60 volts. And RTH value, tell me how much now here, which will get this as a 20. We got the VTH value and RTH value. If so, thereafter what I can do here, Thevenin's model, we can replace it now here. So we need to find the VR value when R is equal to 80. So tell me now VR is, which is given as 80 by, so 100 into 60. So how much this value, tell me? 48. In the circuit, Thevenin's voltage and resistance across the terminals X and Y is. Right. Thevenin's voltage and Thevenin's resistance across the terminals X and Y is required. Tell me now here we don't have any dependent sources now here. So directly we can do the So directly we can go for the basic method. Tell me now here, if I say this voltage is VTH, now so this current, it's an open path now, there is no flow of current here. Now you can tell me this current is 2 amps, and so this current is, and here this current is 2 amps, so that means this voltage, which we can say this as a 40 volts. This voltage is 40 volts, and here this voltage is 60 volts, and you can see now how much this voltage here. So this is 80 volts. Now can you tell me now here voltage across this element? Can you tell me voltage across this my ideal current source? Ideal current source voltage will be depends upon other elements. Now tell me. So how much you will get, you tell me now here, which is VTH. So can you tell me the VTH value, how much you will get now here? If I call this value something Vx, if I say by writing the KVL in this loop now here, minus 40 minus 80 plus Vx minus 60, which is equal to 0. Now can you tell me the Vx value कितना आएगा हमको बोलिए? Vx value, so this is 180, isn't it? Plus 180 or minus 180? Plus 180. So now I need to get this value, this VTH. Now we can apply KVL here. So here if we apply KVL here, now tell me it is minus 80 and plus 180 minus VTH, which is equal to 0. So tell me the VTH value, how much will get? 100. VTH value 100. So whatever the RTH value, tell me. RTH के लिए current source को open करो, voltage source shorted. So then tell me it is open now here, and these two 100, isn't it? Check it now here. This and these two parallel. So that means 80 plus 20. So how much this RTH value, tell me, which is equal to 100 ohms. And D. Next, find the Thevenin's equivalent resistance of the circuit to the left of the terminals marked AB. Okay, so here you can see the dependent element is there. Here we have what we have, dependent element is there. So what I need to do here, if we have a dependent source is there, we need to go for the, and we'll need to go for what, you tell me. What we'll do here, we'll go for the VTIT method. We'll go for the VTIT method, all of you. So let's do the VTIT method since we have dependent sources present. Now this voltage is given as VI. And this is 10 VI. VI, and here this voltage is 5 volts. And now we are going for the VTIT method. So this is my VT and this is my IT. And here this is 2 ohms. Now here you can see this is open path now here. There is no flow of current. So I can write the KVL in this loop. If you write the KVL, tell me the VT, which is equal to what I can say here, 2IT minus 10 VI. Now I have to eliminate the VI. How we can eliminate this VI, tell me. And here this current is an IT. Now if we write the KVL in this loop, you tell me now here, what we'll get now here, minus 5 plus VI and plus 2 into IT minus 10 into VI equal to 0. So now from this we should eliminate the VI value. So this means we can say here 9 VI, which is equal to, tell me now here, minus 5 plus 2it. So that means Vi value which is given as, Vi value given as, so this is minus 5 by 9 into plus 2 by 9 into it. Now replace in this equation Vt which is given as 2it minus, how much is value here, 50. 50 by 9 minus minus plus now here, minus 20 by 9 into it. Yeah, tell me from this what I will get now here. From this my Vt which is given as 50 by 9 plus it we have taken common, that means it is minus 2 by 9. Check it all of you. So this is the equation हमको मिलेगा. From this, can you tell me the value of VTH value? VTH value which is equal to 50 by 9 and the RTH value which is given as minus 2 by 9. So कौन सा option, tell me here? Yes, nearly this option D you can see. Done. Right. Next. Take the next one. Which are the following combination of open circuit voltage? VTH value and RTH value they ask him to find. They ask him to find the VTH value and RTH. So we have dependent sources there. So what I should do here? We'll go for VTAT method here also. Here also we are doing the VTAT method. This is my VT and this is my IT. Right. Now you can tell me now this current is IT. Right. And this current is what you tell me 99 I1. And this current is given as I1. If we write the KCL at this node, tell me sum of entry equal to sum of leaving. So that means what I can say is I1 is a entry current, 99 I1 is also entry current, and which is plus IT is also entry current, IT also entry current, which is equal to 0. So from this I can say IT which is given as minus 100 into I1. IT equal to minus 100 into I1. Now if I write the KVL in this outer loop, KVL to this outer loop, tell me the equation now here, VT which is equal to what we can say here, yes, 1K. That means 10 cube into IT plus 1. Second. If you add the KVL to this outer loop, so what I will get, you tell me. Now this current, how much you will get this current here? This current is an IT here, which is equal to minus 10 cube into I1 plus 1 volt. So that means VT is equal to, and I1 is equal to minus 10 cube into I1 is equal to, tell me now here, that is minus IT by 100. Yes, plus 1. So tell me the VT value, tell me how much will get here, plus 10 into IT plus 1. Check it all of you. So that's why, so kaun sa option, tell me now there. Now VTH value, how much the VTH value? 1 volt. And RTH value, how much it is? 10 ohms. So option A. Next. Find VA. Find VA for maximum power is transferred to the load. For the maximum power transformation, so here the source network must be the Thevenin's form. So the source network is already in the Thevenin's form में है ना? Fine. Under MPT condition, so what is the voltage across my source resistance here? This is off. And either this voltage, how much you tell me now? Off. So this is a 10 volts, 10 volts. Now, so that means how much this current you see here? This current is zero point 0.1. Now this at this node the current is 0.1, this voltage here which is 10 volts. And if we write the nodal equations, tell me now here 0.1 is the entry current which is equal to, now this is 10 by 200 is a leaving current, plus what we can say now here 10 minus VA by 50. This is also leaving current. And we have a simple equation now, we can get the VA value from this. Now simplify, get me the value of VA. So how much the value of VA you tell me? Tell me the value of VA. How much you'll get? VA value? Hmm? I think VA value is 7.5. Isn't it? Check it all of you. Isn't it? Done? The value of Rx so that power dissipated in it is maximum. So here this value of Rx so that power across this Rx is maximum. So that means under MPT condition, so here this load resistance must be equal to Thevenin's resistance RTH. So we need to find the RTH value, we should find now. Now this is when I have shorted this thing here, this load is shorted and these two are parallel, isn't it? And these two are parallel and then the whole combination is under series. So now you can tell me the RTH value, how much we'll get here. So this is 5.6K parallel to 7.6K and plus what you tell me 10.4K parallel to 19.4K. Now simplify, get the value of RTH. Simplify, get the value of RTH. No, yeah, I think you will get the answer as a 10K. Check it all of you. Done. Next one. The VI characteristics as seen from the terminals A and B of the network is shown if the variable resistance RL is connected across the terminals A, B. The maximum power that can be supplied to RL is. Now, tell me now these coordinates here. So from this diagram we can say VTH value which is equal to 20 volts. Next, what else we can say now? This is ISC value, short circuit current, which is equal to 4 amps. From this I can say RTH value, how much you tell me now here? So that is given as VTH by ISC. VTH by ISC. So the RTH value which is given as what we can say here? 5. Now they are asking to find the maximum power now here P max. So the P max which is given as, tell me, VTH is squared by 4 RTH. VTH is squared by 4 RTH, and which is given as 400. 400 by 4 into 5. So how much this value, tell me? 20 watts. Right? Tell me the value of R which will enable the circuit to deliver maximum power to the terminals AB. Now they are asking to find what could be the value of R so that we have a maximum power across AB. For this purpose, you can see now this current source is open circuited, and this current is open circuited, and this voltage source is short circuited. Now you tell me now here, this is open, now here 5 and 1 are parallel, isn't it? So that means what is my RTH value, tell me now here? It is 1 parallel to 5. So which is given as, tell me, 5 by 6. Next, consider the circuit shown in the figure. The Thevenin's equivalent resistance. Thevenin's equivalent resistance. Equivalent resistance we need to find across PQ. Now, here we have dependent sources there, so we'll go for the VT. Dependent source is there, so we'll go for the VTIT method, right? So use the VTIT method. So this is my VT, and here this is my IT. Now you can see now here, and this voltage across this element which is equal to VT. So that means what I can say, this is I naught which is given as VT by 1, so that is a VT only. And you can see now this voltage across this element which is a 3 into I naught, and the voltage across this element which is given as, tell me, 10 volts. 10 volts, and so this current which is equal to 10 amps, right? Now, so what we can do, this current entry current is IT, and this current is I naught. This current is, what you tell me now, IT, right? So since here at this node we don't know this voltage, let us call this node voltage, I am calling it as Vx. I have taken this as a ground. Ten volts. Where is 10 here? 10 volts resistor in between. Where is 10 volts resistor? All these are one only na. Why 10? Here. This voltage 10 volts na. So voltage across this element, this voltage and this 10 volts is exactly parallel to this elements or not? 10 volt source, this element, isn't it? Exactly the what is the voltage across this element, you tell me. Then how these two elements are parallel to each other, right? That's why. Now, and if I call this voltage is a Vx, so I can get this voltage, you tell me here, this current which is given as, what I can say now here, Vx by 1, Vx only, isn't it? Now this is my Vx entry current at that node. I naught is a entry current, plus Vx is also entry current, and that is nothing but IT. Now as we know, I naught is nothing but Vt plus Vx. To get this Vx, now we are applying a KVL in this loop. Tell me KVL in this loop. Minus 3 I naught plus Vt, and then what you tell me now here, minus Vx and minus 10 which is equal to 0. We need the Vx value, right? So that means minus 3 into I naught is nothing but Vt only. Vt plus Vt minus 10, which is equal to Vx. Tell me now here, Vx is equal to, tell me, Vx value from these equations. We can get this as minus 2Vt minus 10, which is equal to It. So tell me, I will get this as minus Vt, which is equal to It plus 10. So from this Vt, which is given as minus It minus 10, and from this equation we can conclude, you tell me, how much the VTH value, tell me. VTH is minus 10 volts. And what about the RTH value, tell me. RTH value, which is equal to minus 1 ohm. So here I got this RTH value negative. Will the RTH value can be never negative or not? Will the RTH value can be negative or not? Yes, RTH value negative भी हो सकता. Yes, the negative value of this RTH is because of what, you tell me? Because of presence of dependent elements, because of presence of dependent sources. If the network contains dependent sources, RTH value may be negative also. The negative value of RTH will indicate that the nature of the network is active nature. The nature of the network, what we can say here, active nature. Right. In the circuit shown below, the maximum power transferred to the resistor R is. We need the maximum power transferred to the resistor R we require. Tell me here, in this case, we need to find what now here? VTH and RTH is required. So let's find the VTH and RTH values. We apply source transformation here. Five, this is 10 volts, and here this is 3, and this is 6 volts. Now here this voltage is my VTH now here, and so this is 5, this is 5 volts. Tell me the VTH value. So VTH minus 5 by 5, right, plus VTH plus 6 plus 10 by 5, which is equal to 0. Tell me how much the VTH value. Simplified these equations. Tell me how much the VTH value. Hmm? VTH value 5.5, isn't it? VTH value plus 0.5 or minus 5.5, and which is equal to minus 5.5. Check it all of you. VTH is minus 5.5, and what about the RTH value? Tell me. RTH value 2.5. We need what now? Maximum power, P max. So the maximum power which is given as, what I can say here, VTH is squared by 4 RTH. What about this one here? What are 6 volts? 6 volts is also there na. So the P max, which is equal to 3.025. Done. Next, the circuit shown in the figure, the maximum power delivered to the resistor R is, the maximum power delivered to the resistor R. So can you tell me the VTH value across my load? This is VTH. So the VTH value which is given as, I can say here, we can apply VDR, that is 40 by 50 into 100. That means how much we'll get now here? 80 V naught. Now from this here, V naught value which is given as, what we can say now here? 2 by 5 into 5. So V naught value which is equal to 2. So that means how much I can say the VTH value? VTH value which is equal to 80 into 2, which is equal to 160 volts. This is 160. Now we need to find the RTH na here. RTH ke liye, so this is shorted, means this will be, how much is value? 10 and 40 are parallel. So whatever the RTH value here, 10 parallel to 40, how much will get? You tell me now here. That is 400 by 50. So how much is value of RTH value? Tell me now. 0 will get cancelled, which is equal to 8 na. 8K. We got the VTH value and RTH value. From this we can get the power. So tell me the P max. The maximum power which is given as VTH squared by 4 RTH. VTH squared by 4 RTH. Tell me now here how much it is. 160 into 160 by 4 into 8 into 10 cube. So how much will get? Yes, which is equal to 0.8 watts. So this is resistance is K. Resistance is in kilowatts na. Okay, 800 milliwatts. Okay, 800 milliwatts we can say. While finding the RTH, we need to short the dependent sources na. Independent source को short करना पड़ेगा. So here, when I shorted this thing here, so that means how much the VT value? Tell me. VT value 0 होगा ना. If the VT value 0, then what happened to this value? This value be 0. This value means, this 0 means short होगा ना. While finding the RTH, the basic method is what now? To find the RTH value, depend all the independent sources has been deactivated. right? Next, in the circuit shown below, Vs is a constant voltage source and IL is a load. The value of IL that maximize the power absorbed by the constant current load is, and here this is my load, this is my load. Tell me now here, and let us call this voltage across this one is something VL if I say. Now what is the power across my load, you tell me now here, which is given as VL into IL, and here this current is IL. So if we write the KVL in this loop, now tell me now what I will get now here, Vs which is equal to R into IL plus VL. So that means VL value given as, tell me here, Vs minus R into IL. So I can say the power PL which is given as Vs minus R into IL into IL. Now tell me now PL which is given as Vs into IL minus R into IL square. This is my power. Now, so we need to find the value of IL value, we need to find, so that power is a load power is maximum. That means what I need to do here, differentiate the power with respect to IL, differentiate the power with respect to the IL. If I differentiated with respect to IL, so what I will get now here, Vs minus 2R into IL. By equating to 0, I can get the value of IL which is given as Vs by 2R. So IL must be equal to how much here? Vs by 2R for the maximum power. Option B na? In the circuit shown, the Norton's equivalent resistance, across the terminals AB is, Norton equivalent resistance means what now? Thevenin's equivalent resistance only. So here we have a dependent sources are there now. So we'll go for what you tell me, VTIT method. We'll go for the VTIT method. This is my VT and this is IT, right? Now, and you can see now here, so this whole voltage across this complete branch which is equal to VT only, right? Now let us write the nodal equations now here, VT minus 4i, by 2 plus VT by 2 plus VT by 4 which is equal to IT, right? And you can see now here how much is I value, tell me. I equal to Vt by 4. I equal to how much here? Vt by 4. So now replace now here, and Vt we have taken common, then it is 1 by 2 plus 1 by 2 plus 1 by 4 minus 2 into I. I is equal to, tell me now here, Vt by 4. Yes, which is equal to IT. Now you can tell me now here 1, so which is equal to 5 by 4 now, Vt which is given as 5 by 4 minus 2 by 4 is equal to IT. tell me now here VT, which is equal to 3 by 4 into IT. So that means what I'll get now here, VT, which is equal to 4 by 3 into IT. So this is my RTH now, tell me. So that's my RTH, which is given as 4 by 3. Then all of you. Fine. All of you do like the session, everybody, and share to all your friends. Share to all your friends. Right. Next. Say the next problem. So they are asking to find the VTH value. Asking to find the VTH value. Now tell me now, he also will go for the VTIT method. So here, and you can see now here, the first observation which we can say, this is my VAB, where VAB equal to VT. VAB equal to VT. Next, and at this node voltage which is equal to VT, let us call this voltage is something Vx. Now let's write the nodal equations at the two nodes. Now here we have super node is there now. So Vx minus 2 by 1 plus Vx by 1, yes, and jump the other end of a super node Vt by 2, and which is equal to It. Right, so this is 2Vx plus Vt by 2, and which is equal to 2 plus It. And the super node equation is given as, tell me, that is my Vt minus Vx, which is given as 20I. Right, and where I is equal to, tell me now here, I is equal to Vx only. I is equal to Vx only. So that means Vt, which is equal to 21 into Vx. So we can replace this relation here now. That is 2 into Vx is equal to Vt by 21 plus Vt by 2, and which is equal to 2 plus It. 2 plus It. Now simplify this equation. Simplify this equation, get the value of Vt. Hmm? So simplify this equation, what will get the relation, tell me? Vt, which is equal to how much, you tell me, 84 by 25, isn't it? Plus 42 by 25 into It. Check it all of you. So we need to get what now? VTH now here. VTH value 84 by 25. 84 by 25. Check it. Right. Done. Next one. Now tell me the next one here. And here they given these values, two sources, the Thevenin values they given. Now let's talk about the first source now here. If I call the source X, for source X, what we can say now here, VTH value, which is equal to 4 volts, and ISC value, that is 2 amps, and RTH value, and which is equal to 2 ohms. Coming to the source Y, and tell me here VTH value. How much the VTH value? We can say here 3 volts. VTH value 3 volts here now. And ISC value. What are the ISC value? Which is equal to 3 amps. So then RTH value. How much here? 1 ohm. Now this has been connected like this. Now you can see now here this positive is connected to negative now aiding. So this means how much the total overall VTH value, tell me. So the overall VTH value 4 plus 3 7, and then these are connected series, so that means I can say this as combiningly, and this is the 7 volts and this is the 3. Now they given as how much this resistance value given as 1. Now you tell me we need the current here now. So can you tell me how much this I value, tell me here? That is 7 by 4 amps. 7 by 4. Next, the circuit shown in the figure contains a dependent current source between A and B. The Thevenin's equivalent resistance, okay, we need to find the value of VTH, and RTH we should find now. We are going for the VT-IT method. So this is my VT and this current is IT. Now, so here first observation, what I can say now, where Vx is nothing but Vt only. Vx is equal to Vt. Now here this current is 10 power 4 into Vx, this current is IT. Now this current is a sum of these two here. If we write the nodal, so KVL to the outer loop, tell me now here 5 into 10 power minus 3 into IT, next plus 5 into 10 power minus 3 into what you tell me now here, IT plus 10 power minus 4 into Vx plus 10. So tell me now here Vt and which is equal to, tell me here. So this is 10 into 10 power 4 into IT plus, and which is equal to 5. So it means 1 by 2. 1 by 2 Vx. Vx is equal to Vt plus 10. So tell me now what I'll get now here. Vt by 2, which is equal to, tell me, 10 plus 10 power 5 into IT. So that means Vt, which I can say this as 20 plus 2 into 10 power 5 into IT. Here we need what now here? Resistance is required. So that means we require the RTH value now. RTH value, which is equal to how much, you tell me? Ten power minus 4. Now this is 10 power minus 4 into Vx now. which is equal to how much, you tell me? 20k na? ठीक है, 200k, 200k. Hmm? Oh, here 10 power 3 only, na? Is how much? 10 cube. No, 10 power 4. Here is how much? 10 power 4. Shubham, so here the method what you used to follow, that method is different method. That is a different method. We are not following that method. So here in this method we'll get the VTH value, ITH value will get directly. This is another method. So this method is a VT80 method. Here we'll get the VTH value will get, and RTH value also will get directly milega. This is one good method. We used to follow this method. Next. Assuming both voltage sources are in phase, the value of R for which maximum power is transferred from A to network A to network B. So this is the circuit here. This is my source now here. Here this is my source, and here this is my load here. And source is Thevenin's form में high, right? So under MPT condition, this voltage, how much this voltage here, which is a 10 volts by 2. So this is 5 volts. How much this voltage here under MPT condition? 5 volts. And this voltage, and that is also 5 volts. So then this current, which is equal to 1 by 4, that means 0.25 now. This current is 0.25, right? Now this voltage 5 volts. Tell me now here 0.25, which is equal to what I can say here, 5 minus 3 by R. So that's why R is equal to how much we'll get now here, 2 by, so here which is equal to point, sorry, this current is how much here, 2.5 na, sorry, how much this current is 2.5 na. This current is 2.5. So that means 2 by 2.5. So how much this value of R is, tell me? 0.8 ohms. Done. The impedance looking into the node terminals. This is one of the very famous problem. We did this problem so many times, I think so. Now here also we are going for VT80 method. and this is my 99 IB, and here this current is 1K, this current is 1K, and this is IB, and this current is 9K, right? Now tell me now here this voltage at this location which is VT. Now tell me now here IB is entry current, IB which is entry current, and 99 IB is also entry current, 99 IB also entry current at this node, and which is equal to, tell me now here, VT by 1K, and this is, and IT also entry current only. So that means what I can say now, this is IT plus, so this is 100 IB which is equal to VT by 1K. Now tell me now here how much is IB value? IB value which is given as 0 minus VT by 10K. So replace this value here, IB. So this means IT minus 100 VT by 10K is equal to VT by 1K. Now simplify this thing here and we can get this value. So how much we'll get now? This is IT which is equal to VT, we have taken VT by 1K, we have taken common, then it will becomes, what you tell me now here, 10 will get cancelled here. So simplify this thing here, how much we'll get here? Finally we will get this relation as, you can tell me now here, VT which is equal to, how much you tell me, 50 into IT milega, check karo. So that's why this RTH value which is equal to VT by IT. So how much this value, tell me? That is 50 ohms. Check it all of you. Hmm? Next. And this is one of the very good problem. Now they given that when 10 volts DC is connected at port 1 and they has observed the following combinations. So here at port 1, this is a port 1, this is second port, this is my network, and you can see now here. So according to Thevenin's theorem, so we can convert into Thevenin's network, we can made it now here. This is my VTH, and here this is my RTH, and this is my load element. Here is a load element RL, and you can see now here. So this source is at 10 volts, and we can see now VTH which is given as, tell me now here, and this current, if I call this as IL, so which is given as IL into RTH बोलिए plus IL into RL. This is the expression you can see. So now from this VTH value, first condition, when IL is equal to 1 ohm, the current is given 3, right? So that means 3 into RTH plus IL is how much here? 3. So 3 into 1, 3 volts. Now when 2.5 is given as load resistor, current is given as a 2. So that means I can say VTH value which is given as, so that is 5 by 2. No, current is 2 na. So current is how much here? 2 into RTH plus what we can say now here, the voltage is equal to 5, and the voltage is 5, and we have this equation, and from this equation we can get the value of VTH milega from this. Can you tell me how much we'll get the VTH by equating these two? So we can say this as 3 RTH plus 3, which is equal to 2 RTH plus 5. That means RTH value which is equal to 2. RTH value 2. So whatever the VTH value, so 6 plus 3, 9. Tell me here, we got the VTH value and RTH value हमको मिला 2 volts and 9, 2 and 9 हमको मिला. This is the scenario when the VS value given as a 10 volts. Now what they did now here, for the same network is same, but they change the port 1 voltage, they change it to 6 volt, they have changed. So the port 1's voltage they change it to 6 volt, they have changed. So then see what happens now here, when they change the 6 volts, when the source voltage 6 volts, here RTH value same. Yes or no? RTH value does not changes now for same network na. RTH value 2 volts only. RTH value 2 volts only. And what the data they given? When the 6 volts case, when 1 ohm is connected at port B, the current is given 7 by 3. Means VTH which is given as I into RTH plus IL into RL. They given how much this resistance value 1, the current is given as 7 by 3. So from this VTH value, current is 7 by 3, RTH value to same hai na, and current which is equal to 7 by 3, IL value 1. So can you tell me how much will get the VTH value? How much will get the VTH value, you see? How much will get the VTH value? Which is equal to 7 volts. Isn't it? When the 6 volts is the voltage at the port 1, we are getting the VTH value, we got 7 volts we got. अगर आपने ध्यान से देखा तो here when this voltage source voltage 6 volts VTH value 7, ये कैसा possible होगा क्या? So we got this thing here. That means what the scenario you tell me now here, and abhi tak, so here they are saying that we have only one, so they are talking here port 1 source. Inside the network also we may have sources present or not. Thus what are the sources present inside the network, they are not mentioned here, you see. They are talking about the sources which are outside the network. That means at the port 1 source only they are talking. So what we can say, अगर आपने ध्यान से observe किया तो when the 10 volts is supplied, when 10 volts is given, so how much the VTH value we got? 9 volts we got. And whatever the RTH value you see, RTH value which is at 2. And when the port 1 the voltage is 6 volts, we got the VTH value how much here, 7 volts हमको मिला. RTH value to same है ना, tell me, that is also 2, right? Now abhi, so in the entire problem they are talking about the amount of the sources present at port 1, but they are not talking about the sources inside the network. That means inside also we have a net sources, but those sources are not disturbed. Yes or no? So here we use the SPT. Why? Because the network is a linear network, you see. since it is a linear network, I can say the response in any element can be expressed as linear combination of individual responses. I can say K1 into Vs and other sources present, but those are not disturbed. So that's why I am taking this as a K2. Now you tell me now here, VTH value 9 volts when K1 into Vs value how much here, 10 plus K2. K2 is not disturbed here, so make it as constant. Next, which is equal to 7, and this given as K1 into 6 plus K2. Now we have two equations and two unknowns. By solving these two equations, we can get the values of K1, K2 values. Tell me. So, can you tell me how much the K1 value will come? That is 1 by 2. And the K2 value how much here? 4. We got this K1, K2 values. Thereafter, what I can do here? I can replace now the VTH value, which is given as, tell me, 1 by 2 into Vs plus K2. K2 value how much here? 4. So this is my expression now here. Now the new value of source voltage, and how much is port 1 voltage they given? 8 volts they given. In this case, we should find the VTH value. Tell me how much the VTH now here? That is 1 by 2 into Vs value 8 volts plus 4 na. So that's why, so VTH value kitna aayega here? 4 plus 4. That is VTH value how much, you tell me? That is 8 volts. This is one of the सबसे बढ़िया प्रॉब्लम अभी तक इतना साल में गेट में. यस, ये तो बहुत बढ़िया प्रॉब्लम अभी तक मिला. इतना से इससे बढ़िया मैंने नहीं देखा. ये प्रॉब्लम बहुत बहुत बढ़िया प्रॉब्लम. या सो लेंथी, सो मच कॉन्सेप्चुअल भी है ये प्रॉब्लम. यस, ये प्रॉब्लम एग्जाम में सॉल्व करना भी बहुत मुश्किल होगा, आई थिंक शायद. सो ये तो बहुत बढ़िया प्रॉब्लम. ये या गेट 2012 का प्रॉब्लम आई. गेट 2012 का प्रॉब्लम, ये बहुत बढ़िया खतरनाक का पेपर. गेट 2012 का पेपर बहुत खतरनाक पेपर है. फाइन, राइट, या ओके. सो आज के लिए इतना है. सो हियर एंड विल मीट कल, टुमारो विल मीट. Okay, and in the next class we'll continue remaining sessions. Okay then, chaliye, we'll meet tomorrow. All of you do like and share to all your friends, and we'll meet in the next class. Okay then, see you, bye bye.